Hi, my name is Adi Andrei. I'm going to try to follow the previous presentation by saying that if they showed you the Air Force view on agent-based modeling, I'll try to show you the implicit view. Also because a lot of the questions that I think we're addressing more like from that perspective. So I used to work, I'm a data scientist. I used to work as a contractor for NASA for a number of years back in the US. I also was instrumental in the creation of the first electronic ink display for Philips. Now, you may see that technology in Amazon Kindle. That's how it became popularized. And a lot of others, government and commercial entities. These days, I'm doing consulting in data science out of London. My company is Technosophics. I'm also doing sort of other things, like I'm combining artificial intelligence with psychology, art, and storytelling to create a new kind of technology that interacts with you and is a little bit more like a therapist, or it helps you explore your subconscious and change your life in that way. But today I'm going to talk about data science and agent-based models. So, most people seem to agree that data science is about storytelling. And I'm trying to position agent-based modeling versus typical data science. So in typical data science, you search for patterns, you propose a story of how the system works, you validate the story at a obviously macro level, you tell the story with visualizations and so on. And then the story is used to predict the outcome of future decisions. In agent-based modeling, it's slightly different. You look for the patterns of the components of the system. And as I was saying before, the components of the systems, usually, they're easier to model than the system itself. You propose a story of how these elements work, and then you validate the story at micro and macro level. And then agent-based modeling is more like a dramatic reenactment of that story, instead of just telling it. You put the agents there and you see what happens. They interact with each other, the whole drama that goes on, and all the effects that you'd not normally expect based on, averages. And then the story also is used to observe the impact and the propagation of the decisions that you make. Not just the outcome, but the impact and the propagation. So it's more like a Hollywood movie versus a newscast. So I'm going to tell you a story tonight, obviously, about telling stories about telling stories. The story starts about 5 years ago, and it lasts for about 2 years. And you're going to have to go straight in 20 minutes, so just bear with me. And it's about a case study. I mean, it's about a client that was a large, fast-moving consuming goods company. Manufacturer, which means the people who make the stuff you buy in supermarkets. And they were very excited. They had a department of about 15 mathematical modelers, statisticians, and computer scientists. And they were very interested in using agent-based modeling for a few reasons. For product design, like to predict the performance of a product in the market before it's actually being released in the market, or how is it going to perform in competition with other products, and also for optimization. So they have their current products, they know how they perform, they know how people choose them versus the other products. What can they change to make those products more performant, get more sales. But the immediate need at the point that I got involved with this was for a recommendation system. So recommendation systems, they can be quite tricky, and you can have a whole meetup just on that. But basically, they had just released an online recommendation system for one of their online stores. And they were very good at predicting categories, what category the customer should buy. But they're not very good at predicting what product, what SKU, what in that category should they recommend. And as a checkout recommender, you can't give, you know, like 3 or 5 choices in the same product category. So I think for their initial recommender, they're using market basket analysis, which is very good at predicting categories. Like, you know, if you buy fish, you probably should buy white wine, or you might want to buy white wine. But then, from the 100 different choices of white wine, which wine exactly should they recommend? So this is where they wanted to come up with a consumer choice. And they did lots of literature research, and then from econometrics, they came up with a model. And then we decided we're going to go for the first product category we're going to focus on was going to be mayo, mayonnaise. So what's the problem with mayonnaise? When you go to a supermarket, some of you may be aware, but probably most not, you do have 96 choices. You really have 96 choices. And it gets worse with other products. So which one to recommend? In the bottom corner there is just one brand. One brand, 13 different choices. They're all different things. Different sizes, different compositions, and you have 8 to 12 brands. So the first step was to look at the factors that influence that choice. Now, in the bigger picture, what I'm doing, as you saw from agent-based modeling, first you have to come up with a model, then you have to test and validate it, and then you do simulation and you use it, and then this thing kind of reiterates. My story is going to be in coming up with a model and a little bit of verification, and just a couple of iterations of that. So just so you know where you are in the bigger picture. Coming up with the model, it's not easy. I know my friends here, like, they said the verification is the difficult thing, and just coming up with the model is an easy thing. It's not. So there's different factors that influence the choice. Starting with product attributes, and this was the team's idea. Okay, we have, for example, for me, I have sweetness, consistency, and pack size. And then, because they wanted to use, I'll show you later, a linear model, we needed to come up with attributes for the model. And then we're going to estimate weights and so on. So I think most of you are familiar with that process. But so the attributes are going to be around product attributes. So the first is going to be what we call the ideal point distance. The ideal point distance is, if you look here, let's say this is sweetness and this is consistency, suppose. This point here would be a specific product. All these other points here are based on historical data, how individual consumers have preference for these product attributes. So for example, this guy likes it very, this is for a different product, but let's say likes it very sweet, but not very consistent, right? This guy would like it very consistent, but not very sweet. And everybody in between. So also it's part of the market simulator, so they can decide to put the products in this point in different places, and then they would see how it behaves. So the ideal point distance is basically the distance in the three-dimensional or n-dimensional space between the product and the consumer ideal point. Pricing and promotions obviously influence, and then social network effects and interaction. And in this case, we didn't have actual, I mean, it's very difficult to get actual social network. Yes?
Can we ask questions in the middle of this? Or?
Please.
I don't understand. Is each of these point an existing product?
No,
that has been used to do this?
This is the
points?
product. And these points represent the preferences of different customers.
But how do you get the preferences without a product?
You look at historical data and you average it, sort of.
Okay.
But that's what they did. So far is the model that I came to help build, but it wasn't my original idea.
Sorry,
yes?
What does sweetness and consistency mean for mayonnaise?
It means like it can be with more sugar or less sugar.
All right, okay.
We're talking about manufactured.
So it's nothing abstract.
No, it doesn't involve differential equations. And consistency is like, no, it flows.
Yeah,
it's basic stuff for everyday consumers. It's not for data scientists. And social network effects, basically, we aggregate, we define what we believe the social network of each individual consumer is based on location, gender, ethnicity, and household income. And then for each product choice, we assign a certain, let's say, preference of that social network for that product. And this is what the model looks like. The utility for each choice I, it's a weighted sum of the different factors. And there's another factor that another parameter is I'm sorry, was that funny? Yeah, it's called trembling hand, like that. But basically, it's just probability that the consumer is going to make a random choice. So the model is called maximum utility because you assign a utility, you calculate the utility from the perspective of that consumer for each of its for each of the product choices, and then most of the time you pick the product with the maximum utility, but there's a certain percentage of time, or with a certain probability, you pick a uniform random choice. You pick randomly. So by the time I got involved with the project, this was already decided. The problem was estimating these parameters because of this thing being a uniform random choice. There's no mathematical or statistical that we knew at the time. I'm sure maybe some of you now can tell me, but we didn't know any way, using math or stats to estimate the parameters for this model. So we just had to figure out how to do it. And my background is machine learning, and especially nature-inspired algorithms. So what we used for this was an open source particle swarm optimization algorithm that I modified, and I combined it to also do genetic algorithms simultaneously. So particle swarm, if this is using synthetic data, generating the search space just to see how it looks. It has lots of local minimum. Particle swarm, for those who don't know, usually it's like a swarm of agents, again, agents, that they just crawl the space, and as soon as they're in communication with each other, and as soon as one finds a better spot, tells everybody. So they start moving slightly in that direction, and then in the process they find other ones. So they just move like a swarm, trying to find the maximum, the optimum they tend to be extremely efficient, especially in situations where other tools cannot do anything. Yes, please.
So, is there an optimal way to initialize the search? So we should put the agents in sort of the edges of the search space.
Oh, okay, we can talk all night about that. But basically, no, we just throw it at random. It's like throwing those, cyborg ants or something. They tend to come much very fast. You don't really need to initialize it, actually. Yes.
Sorry, is that a visualization of a 5-dimensional?
No, it's a visualization of a synthetic 2-dimensional space that was generated using the model to figure out, how the search space would look like even in 2 dimensions, and then just for visualization purposes, just so you can better understand what I'm talking about. So we had 5 dimensions, and evaluation basically meant running the whole simulation for each individual, and then go to the next step and next step. Eventually, we come up with the right weights. So we had 200,000 transactions, but each transaction, an individual had 96 choices. We were able to predict exactly which one out of those 96, 35% of the time. This, at that time, which is like 4 years ago, was better than anything else we could find in the literature. Trembling hand turned out that it was going to 0 all the time, so the only conclusion can be that if you try to account in your model for things that you cannot account, don't use uniform random choice. The consumers don't make choices using uniform random. Please?
What's the second point? You just click the second one.
Yes, I was going to go to that.
Oh, sorry.
The social network, although it had the smallest weight, it turned out that eliminating it degraded the model significantly. So the social network was important and was one of these parameters. I think in statistics they're called suppressed variables or something, where they have a very small weight. And it looks like you can eliminate them, but actually they're fundamental for the success of the model. Somehow they manage to explain more than we would assume with the linear assumption, which makes sense because real life is non-linear. So, yes?
This question. Have you tried a different model of social network as a parameter here? Because you've got different social models. It can be a random network, can be small world network, can be scale-free network with different properties. And it can be an element, let's say here, so...
Right, that's a very good question. No, we haven't. No, it's very good. We use small world network.
Okay.
That's one of the things when you do these things in the real world. There's other constraints that you have to prioritize what you're going to focus on. And normally when you start doing this thing, it raises more questions than you started with. But overall, I mean, I'm not sure if this is really understood. Like that 35% there, it's 35%. It's like an incredibly good result, let me put it that way, because it's out of 100 different SKUs.
So the totally random choice would be 1%.
Well, actually, we actually ran a simulation where the model picks using uniform random, using the computer generated uniform random, and it came out at 2%. Again, real life versus theoretical. I don't know, maybe there was some bias in the data or something that somehow it came out at 2%. So everybody was happy. We were popping the champagne. And then there was Act 2. I told you it's going to be a dramatic reenactment, dramatic reenactment. So we're like, okay, this is very happy, but how does the model perform on the other categories? So again, probably like 2 or 3 months of work trying to extract all the ideal points, different products, different opinions of what the ideal point, what dimensions should we look for. Like I said with mail, why did we look at those two? I don't know. It's the experts who decided. So we ran the model, and not so good. Actually, on salad dressing, where we have 450 different choices, it was doing, about as well as the random, which, yeah, it was pretty sad. Okay, so some of them were going better than the others, but I mean, this is still not bad. 20% is not bad when you have 100 choices. But what was obvious is that our model doesn't really reflect what's happening because it's not consistent. You need something that at least looks consistent across multiple product categories. So what to do? At this point, I had to tell the client, actually your model doesn't work after they already celebrated that the model works, or to give them a different story. So start looking for a different story, we start doing research, pretty much everything. And one of the nice things in data science is that we don't limit ourselves at one tool. Since I've been doing this for 17 years, I learned that to look across multiple disciplines, especially when it comes to consumer choice, psychology and neuroscience tend to come in handy. So, before that, just backtrack a little bit. One insight that came out when I tried to create a new story was that, okay, what happens to me when I go to a supermarket? And this is the question actually you should ask before you start throwing random forests and things of the data. It's like, what does that data actually represent, and what's the story of that data before you try to impose a story on it or try to forcefully extract it? So buying groceries, it's a massively repetitive task, and people hate making choices or having too many choices. So when I go to the supermarket, I just pick up whatever I always pick up. Or I try something, I don't know how it's going to be, but then if I like it, I stay with that. So I decided to explore a habitual component of this system. So first I added, is this product last choice? Is the last thing that I bought or frequency? Is this the product that I bought the most? Sadly, it did not improve the model. It improved on the other, it improved a little bit on the other products, but it did not improve on the mail. And the mail was like the standard that needed to be better. So what to do? So this is where I started this search and looking at papers and just trying to figure out, okay, what is it? How do we make these decisions? How do we keep choices and repetitive things and so on? Start thinking about memory. So then I came across this thing. This is from, it's very well known in neuroscience. It's Hermann Ebbinghaus in 1885. He did an experiment that was a landmark project because it showed how we have exponentially we forget about things unless we reinforce them. So then we're able to create a habitual model. Here you can see how basically when something happens, when we learn something, in my model I said when we make a choice or we pick one product, then we forget about it. But if we like it, we buy it again. So it gets reinforced. So then we forget about it, but the retention rate is a bit higher. If we buy it again, and so on. And then you can play with the parameters here. Or actually we estimate them using the same method. So we have a new model. The memory value for each choice is part of the model. And there's the results. So it worked. And I'll have here. So we've got consistent good performance across categories, especially in salad dressing where things didn't work before. 50% to 600% better performance than the original model. Also, the coefficient for ideal points were very small. Tried to eliminate them completely, and there was no problem. Which was very good because now the model was completely online. We didn't have to learn and keep updating what the ideal points are for our customers. We can start making decisions right away, predictions. And also the influence of price and promotion seemed to go down. So it basically was a very good result, especially considering the number of choices.
Excuse me.
Yes.
I'm sorry, are these performance metrics based on repeat customers only? Like, do you have to know something about them first?
The only thing we knew about them first was, well, we kind of computed their social network. That was the only thing we knew about them first.
I'm just not sure how the habitual metrics, like, I guess the habitual weights are calculated for those who don't have, we haven't observed any habit.
So those who didn't buy anything, the only thing we can predict is what their social network would buy. Does that answer?
Sure.
How did you simulate the memory value parameter?
Based on this curve. So whenever they buy, let's say, one case of one product, the value for one product goes to 1. And then it starts exponentially to decay. If they buy it again, it goes again to 1, but then it decays, but it decays at a different rate, at a smaller rate.
So you collected a set of historical choices
Yes,
the consumer
yes.
made?
So for each consumer, we have each product that they've ever bought, what level this thing is, the memory value is. Yes.
How do you know with the social network what they bought? How do you know that?
You look at the social network is defined as people in the same location, of the same age, so you have the data. Yes.
What you're predicting is basically, so you get your consumers who come on and you're saying, okay, these guys actually chose mayonnaise. And I'm saying, well, so you have a model which is basically saying, we're given a choosing mayonnaise.
No, it's what exactly of the 96 types of mayonnaise did they choose?
Yeah, exactly. But you're so you're looking at the people who've chosen mayonnaise, right? And you're saying your model is saying you're just trying to predict which particular choice of mayonnaise that actually
Yes.
making. Right?
Yes.
So it's conditional on the fact that they actually chosen. How you're getting a prediction for each person. Are you able to get like a second choice or a third choice? I mean, you're basically saying how accurate you are with your first predicted.
We predicted one choice. We did predict like what would there be the top 3 choices,
yeah, exactly.
And when we did the top 3 choices, actually this shoot up to like it was in like 70s and 80s the model for the top 3 choices.
So that's really incredible.
Yes, but at the checkout, you don't want to be shown 3 types of mayo. You wanted to be shown just one. And maybe for another product, a choice of some other product category, like one mayo, one salad dressing, and I don't know, something. So, yeah, I mean, it's a very difficult problem.
Yeah.
So these results were very good. And then we did a micro level. So that's the thing with agent-based models, right? You have to go and see, okay, at the macro level, does the system behave, or does it work the way we expect it to? Now at the micro level, what happens? So actually, it turned out that for the 30% of the customers, they were doing exactly what we predicted 90% of the time. And then for 30% of the agents, we were quite off. I mean, we were totally off. And then everything else was in between. Yes?
I'm going to question, because you've got weights in this model, and probably as I understand, the weights are global in this model for all agents, or the weights are what were defined for each agent separately?
Again, just to understand how big of a work this can be. The first step was that it's the same for everybody.
Yes.
And then the next step was going to be customer segmentation and the estimation of parameters separately for each one. And the actual next step was going to be that we're not going to have a model, we're going to have a model tree. And the tree decides, in the leaf it has the model. So the tree is being learned, machine learning to learn the tree, and then you have, okay, if this is the kind of situation, then apply this model. If this is the situation, then apply this model. And then put that into a simulation and have all these agents interact with each other. Yes?
You compared it to the baseline of picking a mayonnaise completely randomly, which was like 2%. Did you compare that to going just on what the last mayonnaise that particular consumer had bought?
Yes, so we had the frequency and the last product they bought.
But I mean, what would be the percentage just on the basis of their previous purchase?
Just on the basis of the
previous,
previous.
You get quite relatively high percentage.
It was different. No, it wasn't relatively high. It was probably twice as good as random, which meant like 8% versus our model with the 50. Or I think with one we got even 12% on peanut butter. For if we used the one they bought most frequently, we got 12%. But again, not good enough. The target was to get over 20 to 25 for everyone. So yes, there's many other things. So the epilogue of the story. More questions than we started with. We capture very well the behavioral sound, but not what makes the other different. How is their story different? Can we figure out with the data that we have, and what are the triggers that and attributes that make people behave in a non-habitual manner? So our story was that people buy in supermarkets. They buy things habitually unless they're disrupted by something. And the idea was to look at how promotions can disrupt that, or any other I don't know, external events. But again, there's a lack of data on that. We didn't even have enough data on promotions. But again, yes, that's very good questions to explore. We also had a little bit of a happy ending. They tried the model in the recommender system, and with real customers in real life for a couple of months, and then they said that actually they could see a significant increase in converting recommendations to sales. All right, so I guess this is my presentation. Thank you. I enjoyed doing it. I enjoyed working on this project actually, and enjoyed bringing together. I think this is what this profession makes it nice, because you bring together different perspectives, different stories from different fields that develop in different ways, and bring them all together to create the story of the data that is in front of you. Try to figure it out.
No questions? I have one for you. So, can you tell us what year was that?
2008. Okay. And 2009. 2 years.
Did you guys discuss anything about neural networks at the time for modeling the social net?
No, I mean, we're trying to keep it not so black box. The whole idea was to build the models, to apply, use them in practice, but also to understand, to really understand what's going on. Yes.
So whenever you buy something on Amazon, it always says, people have also bought this, or, gives you that option in the checkout. Do you know anything about their methodology?
Yes, it's very different though, because you don't go and buy the same book over and over and over. Or whatever Amazon sells, you don't buy it repetitively, so it will be quite different.
Because yours is dependent on repeat purchases like that.
Yes, it wasn't initially, but yeah. Yes.
The projects that we did in econometrics.
No, I mean, econometrics was the original model, was extracted from econometrics.
Have you done anything in investments?
I believe. You mean like trying to predict? If you try to predict anything that people do, it's very hard.
But a 20% batting average.
I worked on a project that was doing portfolio optimization, so I'm quite familiar with that.
I guess if you try to if you try to build models not for options but to model traders.
An agent-based model of traders.
Yeah, because then stocks don't have behavior. If you use this approach, you're talking about the traders, and I guess that would be a little bit to.
I normally try to focus on like engineering for this kind of problems.
Yeah.
Especially, it's inevitable. It's important. Yes, please, sir.
Yes, you talked about your clients becoming somewhat secretive after you delivered the solution to a recommender system.
Yes.
But giving evidence that they were satisfied.
No, they said it worked okay and smiled, but they didn't want to give any more details.
Yeah, and you said it was in roughly 2008.
Yes.
I know at least 2 examples of scenarios similar to this, one of which was published in the academic literature prior to that, where it had actually worked. So I think this is an approach that can actually work in FCMD or similar to the receiver role.
Can you mention the paper or the?
There was a paper that was in, I think, the Recommended Systems Conference 2008, which was for a Swiss online retailer.
Okay, this was a Swiss online retailer. I think okay.
But I was working on a different project, which I wasn't mentioning directly, but I'm talking about it later.
All right. Any other questions? Okay.
Well, thanks.